All right. Hello, everyone, and welcome to today's webinar on the exciting intersection of generative AI, large language models, and their transformative role in the field of healthcare. So, I will be, uh, hosting this today, and together we will explore how these technologies are reshaping the health industry. So to start with, let's deep dive into large language models and understand some of the beginning implementations with healthcare and the powerful tools that are capable of performing some of the basic healthcare analysis plus assessment through large language models, right? So before I get into this, I'll quickly introduce CellStrat and the CellStrat community. So we have 17,000 plus members of strong community at CellStrat, and we have been delivering these webinars for almost 5 years, a little bit more, I guess. And at CellStrat, we had been into AI, machine learning, generative AI now, and we also been delivering webinars into data engineering series we started recently, and we will also continue to do in all of these aspects. So while healthcare is like this Unplugged series is new, but we will also have another healthcare series ran by Dolce, who is our healthcare lead, and she is basically taking an amazing course on healthcare and LLMs. So this is an Unplugged series. I'll be presenting every weekend paper, and the paper will be deep dive into LLMs and their use cases in terms of healthcare and the problems that we can solve using these LLMs. So um, these considering this is the first session today, I will be very much into the overall understanding of the LLMs in the healthcare industry. And we will look into a lot of aspects here. For example, my agenda is today is to discuss about the LLMs in healthcare and the effectiveness and limitations of LLMs and their methodologies in the healthcare domain. And the medical LLMs and their benchmarks, like the popular health LLMs and their rankings, applications of the healthcare LLMs. So they may not be necessarily the traditional LLMs like we have GPT 3.5 or GPT 4. It could be also other models like Health Alpaca, right? So these are like base LLMs. So this particular session will be very much technical, and also we will cover a lot of aspects about how LLMs are so powerful and they can get you to that level where you can solve some of the genuine problems that exist in the healthcare industry. So before we get into that, let's understand the landscape of healthcare and what are the aspects that we can cover through LLMs. Although it's a very vast area and it's really kind of impossible for us to have this understanding in one session, and that's why we try to have a series of sessions over the weekend, and every weekend, let's say, and we'll have a connected series with this webinar. Okay, and this is the first day webinar that I will be starting with, beginning with LLMs in healthcare. So one more logistics that I would request all of you. I could see a lot of participants here, and if you have any questions and you want to discuss, please feel free to ask your questions, and I would be happy to discuss those aspects as well. Maybe I will take some questions at the end if it is a lot of questions, but if not, then I can take some questions in between as well. Okay, considering the flow is not broken. So, how many of you are like aware of already like the LLMs and have been doing some work with LLMs? Anyone here working in LLMs plus healthcare? You can just let me know in the chat. That would help me understand the audience. And also, let's be interactive so we can communicate to each other. Anyone here? Okay, I do not see any response yet. Okay, so the overall landscape of healthcare, if you look at these, there are majorly the areas that goes into is patient healthcare, right? The patient healthcare, you have patient empowerment, you have translation and summary, and then you have documentation and voice to. This is just a broad area, but this is going to be huge, because if you just consider patient empowerment, what are the things that you wanted to do? Let's say if I have a smartwatch, or I have a medical device that captures a lot of information from the patient, right, directly. And so a lot of the times that we are not really being aware of, or maybe want to measure that, let's say how is your health throughout, let's say from 2000 to 2020, and you want to see in these 2 decades how your health performance, right? So is it good, or is it like average, or is it improving, or it is decreasing, right? So maybe there are a lot of health vitals and specific measures that we need to think about. I mean, if I just consider one as the area of patient care, there is an enormous amount of work and opportunities that is available, and I think there are a lot of problems that we can solve in each area of this, right? And then we have translation and summary. So imagine that you have a doctor prescription, and you want to highlight all the important points, along with that the summary of what doctor actually mentioned. And a lot of times it is like a lot of details in a lot of diseases like mental health, especially, like there is so much of documentation, and it is very difficult to come up to a conclusion. In those cases also, we can think about translation and summary kind of task. And then we have documentation and voice to text, right? So voice to text is one of the other aspects of patient care. A lot of the times that patients cannot write, or they cannot explain by writing it, or let's say somebody has to hear what is the patient saying. So when somebody is dictating and writing it, right, you can have in voice to text format, where somebody can speak and it can be written into textual form. So once it is in text, you have the digital evidence of that information, and then further that can be processed through LLMs and other means, right? So these are like some of the aspects of patient care. And then we have medical knowledge. A lot of the times we don't know about some of the basic knowledge that may require. Let's say if I have some symptoms, is it like early symptoms of diabetes? Is it early symptoms of blood pressure or something like that, right? So if I need to know those, and if I specifically know what sort of questions I should be asking, and if there is an tool that can guide me to ask the right set of questions, that's about it, right? That's kind of, it's not giving you diagnosis, but it is kind of driving you to the right path for figuring out the early symptoms of a disease. And then you can go for a doctor suggestions, and you can take the next steps from there, right? So that's on the patient care side, and what I wanted to discuss here. And then you have education, right? Education is more of like prompt engineering, critical thinking, personalized education, interactive learning. You can think about healthcare as in, like, so far the doctors has been reading in the books. There are a lot of books that are available in the college, I would say study materials. But what if there is a lot of research and advancement that needs to be learned by these all the doctors, and over the period of time they always keep on doing some research, because the diseases are always changing, and over the time that some of the diseases are maybe well known, that there are so many diseases that are not known to the whole healthcare community. And in that case, if you are, let's say, there is a new research has been done in some part of the world, and if we can combine those information together and bring it to the doctors, the scientific community of the healthcare industry, that would be a really a game changer in terms of how LLMs can, provide such information. And then we are going into the research aspect of it, where we're talking about science communication, programming, access to scientific knowledge, and specific scientific text production, right? So definitely there are a lot of aspects to that. I mean, if you think of one example, if you can feed in an image of, let's say, a molecule, or maybe a bacteria, and then let's say you want it to describe about it, that might give you a little bit of information, and as a domain expert you can augment it further and prepare a proper research documentation. Obviously that you have to take care of the plagiarisms and other aspects, but in a lot of sense that it helps the researchers to come up with better research ideas. For example, in CellStat, we have developed a tool called CellBot, and basically, let me see here. I go to uh, cellbot.ai, and here, so I want to show the test version of it. And here, let's say I wanted to know about diabetes and its symptoms, and I can search for it, and this will give me the specifics related to diabetes. And this is really amazing. I mean, we have like been pulling all the papers from PubMed. PubMed is one of the popular and very extensive library of research articles, right? So let's say you wanted to know about diabetes and its symptoms, and there are some suggestions or suggestive questions. Let's say I want to know what are the common symptoms associated with diabetes and pre-diabetes, right? And I'm going to ask this question, and it's going to give me the answer from the LLM here. And you can see, like, let's say frequent urination, excessive thirst, explained weight loss, extreme hunger, fatigue, and so on, right? And now these papers are pulled from PubMed, which is an extensive medical research library, and I can visualize all these papers that are basically being associated, and you can see like the total number of results and the authors, and what are the research papers that are basically associated to your search, right? This is very kind of extensive way of doing research, and as I showed you in slides here, right? So research is one of the other aspects that the scientific community, the healthcare community, is looking for solutions to, and also a pathway to basically combine. So I want to, let's say, combine multiple research papers that may be in a different format or in the same format, and then you come to summarize and maybe come up with a new paper or new set of research ideas. Yeah. Any questions so far? Anyone? So the diverse set of health prediction tasks that are available. I mean, if you look at these particular slide, I mean, I'm just hiding it here, that not naming any kind of health care based LLMs. Yes, Pranshu, any questions?
Yeah, sir, could you throw some light on what is the potential use of LLMs in the healthcare prediction analysis and predicting the disease before it happens, like in the diagnosis stage?
Yeah, I'm coming to that. Yeah. So the next slides will be within those lines, Pranshu. Yeah. So the healthcare LLMs. I mean, In this, we can have bunch of LLMs that we can talk about, and the different types of LLMs that are available in the market. For example, I mean, I'll just quickly, so as I said, like this is more of like we are going through a paper that is in the summarized version, and I'm going to dissect that paper to give you a better explanation, because the research papers are one of the sources that where you see the recent findings, and also there is a lot of authentic information, because these papers are like the RZ papers. They are kind of there are a lot of information that are being researched extensively, and then you get to a conclusion, or then you come to certain aspects of understanding, right? So there are different set of LLMs. Let me bring that here. Yeah. So if you look at these, um, I'll come to GPT and other models, but apart from GPT, right? You can see. So the first one is ASLPS, right? So it's basically a publicly shareable clinical LLM developed to circumvent privacy regulations by training and on synthetic clinical notes extracted from biomedical literature. Clinical notes are very specific to healthcare and healthcare specific information. If you compare these SLPS and with any other model like GPT-3 and 3.5, other than the size advantage, there is no other advantage, because this is kind of very specific to biomedical literature. Now, you might ask this question that whether we should get a specialized medical LLM, or we should get a generalized medical LLM that can do special tasks. And we are going to explore that aspect, that whether a specialized LLM going to perform better, or whether a generalized LLM with better techniques of prompt engineering can perform better, right? Though both are two different aspects of solving the same problem, and we are going to see. So how do you analyze that? How do you actually measure the quality of responses based on the type of LLM that you chose, and based on the problem statement and data set that you have chosen, right? So some of you are, maybe if you have no background with LLMs, please feel free to ask me some questions, and if you want me to explain some of the basics, I will be happy to do that in like quick span of time. But um if you know already, I think this is like the bridging the gap between the LLMs and what LLMs can do in the healthcare industry. Okay, so there are some clinical, the other models like Clinical Camel and Open LLM fine-tuned on Llama 2, 70 billion architecture using QLoRa. And QLoRa is one of the fine-tuning techniques that are used for quantized low rank adaptation. Okay, Ramu has question, how Gen AI will help in scientific knowledge extraction for drug discovery and development. Yeah, I think I gave you one example, Ramu, that CellBot demo, where you can extract information from lots of scientific papers, scientific knowledge. Uh, Given that you have that information available, PubMed is an publicly available medical research data, but there are a lot of research articles that are not publicly available. But if you have access to it, and let's say there are like variety of scientific research, how do you basically as a human, if you think as an human, how do we extract information? We first get, let's say if I read 2 3 papers, and from there I got to know about some aspect to it, and from there I can actually dissect and distill the knowledge, right? So knowledge distillation based on different set of sources, different papers, scientific papers, is kind of a very useful application in the Gen AI, because Gen AI is, it can help you like mine that information. So if you know about the information mining technique in LLMs, right? What do we do? If you have a PDF file, you can extract all the text from the PDF file, let's say a research paper PDF file, extract that information in the text form. You can convert them into vector, store into vector database. I can have millions of papers that goes into vector database, and then you can basically ask your questions to combine that result together and create or generate a new results from it, right? I'm just giving you a very high level idea, because RAG is something is I expect you to have some knowledge about RAG. But if you wanted to know about it, I will deep dive into RAG techniques later on in our later upcoming webinars, where I will go into like specific architecture of an healthcare LLM, and then from there we can deep dive into RAG techniques and specialized RAG techniques in the healthcare LLMs. Okay, so Plant T5 is an instruction fine-tuned version of T5, or text to text transformer model. It's a very early. I mean, I think in 2022 or 2020, yeah, 2022 it came, and it was a very popular model with the 3 billion parameters. So if you see these parameters, right? Parameters are like kind of size of the model. So generally, you can think in this way, very in layman term. Size is like, how big the model is, how much data the model is trained with. If you have trained with, let's say, 20,000 books, and if you have trained a model with 10,000 books, what do you think, which model will perform better? It's not about the volume. Let's be very specific. Obviously volume helps to some extent, but it is also about the quality of the books or the knowledge that you have got the model trained with. Yeah, Pranshu, you have any questions?
Hello, sir. So wouldn't using generalized LLMs be more useful in this case compared to specialized LLMs that you have used? For example, Llama 3.1 405B that has a lot of more parameters than the listed above. That is only 7B, 70B. I think that would be more useful in this case.
Yeah, so we can't say, as I said even at the beginning, that we can't say if the size of the LLM is bigger, that's going to perform better. Asclepius or Asclepius, whatever, Asclepius, let's say. So this model has only, I think, in millions of parameters this model is trained with, and it performs, let's say in this case 7B. This model, which is specially trained with biomedical literature, can perform in a lot of tasks better than GPT 3.5 and 4. So again, it depends on the benchmarks and the type of data set and the type of task. So in NLP, there are two things that plays. So all of these are, even if you are going into healthcare domain, all of these are nothing but an NLP problem, right? We call it Gen AI, we call it LLM, we call it healthcare with LLM. So healthcare is a specific domain. Let me write it here at the top. So let's say healthcare is in a specific domain. We are combining LLMs to that, right? Now, LLMs are just helping you, distill the information that is in existing documents or the model that is trained with. If the model is trained with healthcare data, we can expect that this model is kind of very much specific to a specific domain. Now, when we're talking about domain, let's say I have I have a data set. Okay, the data set is clinical trials. It can be a drug discovery data set. It can be a data set specific to, let's say, disease or the disease findings, right? So those are like specific data set. But what if that you do not have a specific data set, but the model is trained with globally all type of healthcare, all type of, let's say, general medicine or non-healthcare data as well? Will that model perform better than a model that has trained with specific data set from the healthcare industry? This is a bigger question than what LLM should we use? What should be the size of the LLM? Because size of the LLMs, lot of times it may be irrelevant. Because I can give you one example. If you have to know who is the prime minister of a particular country, you don't need to search through 300 billion parameter model, isn't it? It's just a simple query. Why do I need such a huge LLM model to answer such simple queries? Similar to in healthcare industry, if you have some basic questions about diseases or health related questions, you should not have a huge LLM for that. Not necessarily, right? And it also kind of gives you, because the cost of the LLM and also the business use cases that you are solving sometimes cannot work well, because getting an ROI from these kind of models, these are like very costly operations and deployments over the cloud, or even if you do on premise, it's not a cheap solution, right? So you need to think about the cost complexities, and also the in terms of how you can efficiently deploy a proper LLM that fits your use case. This is where domain expertise plus your LLM understanding will come into picture. There's a question from Ramu. Thanks. Could you please share any relevant reference documents or public pages and architecture diagrams? I have a lot of things in these slides, Ramu. Beyond that, if you need, I mean, I have lots of information. I mean, I can share some, and even if you Google yourself, you will get a lot of information. But I will share one or two that would be very specific to today's webinar, right? Because it's an, we are living in the era of information explosion. So we have no limitation to information, but we should be very specific about what we should be learning about and what should be looking for. Okay, so moving ahead with this discussion, that we have a lot of medical specific LLMs, like now Biomed GPT, which is again a 7 billion parameter model, and open multimodal generative pre-trained transformer for biomedicine, which closes the gap between natural language modality and diverse biomedical data modalities via large generative language models. I'm talking about these. You don't need to really remember that what is this model, but I'm going to compare these models against GPT-3 and 3.5 and GPT-4, so that we can get a better comparison of how or what could be the quality of good healthcare LLMs. Okay, that's the perspective of this first day webinar as well. BioMistral, which is a Mistral-based further pre-trained open source model suited for medical domains. And then we have Llama 2. We all are familiar with Llama 2, Llama 3 by now, whoever working with LLM now. If you are from healthcare industry, you may not be familiar with it, but that's okay. You can just consider it another LLM. Okay. So Meta AI is open LLM, which possesses features of including a longer context length, training, improved training on larger data set, and fine tuning via RLHF and greater performance. So basically, these models are like very specialized models, and they are trained with special techniques, but they are not specialized models in terms of data. Okay, so we talked about the previous models here, which are like specialized model like Biomed GPT or species, right? So these are like very specialized models. Now, GPT 3.5 again has 175 billion parameters. GPT-4 has more than 2,000 billion parameters. So 2 trillion, right? So huge set of data. And similarly, we have Gemini Pro, right? It's a 2020. Again, so Gemini Pro also has been trained with lots of data, and Google DeepMind's versatile model optimized for diverse tasks across text, code, image, and audio. So they have trained with multimodal data here. That's also one of the advantages of using such models. Now, as I said, it is again that, if you if you go, if you have to buy a car, you always need to think about what is the family, the size of the family, what how much usage you have, what type of, like, usage you have, how much kilometers you drive every month. Based on that, you decide which car to buy. Let's say if you are like very much into into resource, optimization. So similarly, like, instead of choosing a random, let's say GPT 3.5 or 4 for a medical use case, we all, if we have that knowledge and understanding that which model is kind of get you the better optimized solution for your use case, this is very important to understand these different type of models that are available, and also test out that, because nobody can tell you, hey, go ahead and use this because this is the best car for you, or this best model for you for your use case, because you have to trial and experiment with it. Unfortunately, this is the time that we are living in, every day with new models that are coming in the era. And also, some other, like, if you've deployed and you figured out a model, tomorrow you will get to know, okay, there is a better model than that, and some competitors are using that model, right? So basically it's a challenging time, but I believe that in an informative decision will come from these understanding of the LLMs and how they work with different set of problems and data sets, and what is the behavior of LLM and what drives the behavior of LLMs. Okay, so I will come to results and everything. Let me go ahead here. So there are a lot of type of information that comes from different type of sources. For example, logging apps. So if you have a smartwatch, if you have a phone that tracks your, let's say, if you're going for a morning walk, or if you are checking your heartbeat, or if you're checking blood pressure, etc., etc. So those comes from different logging apps. Then there are medical institutions, or hospitals that also has a lot of information related to medical, or health related activities that are happening, and wearable sensors or user surveys. A lot of times that a lot of information that comes from public survey that happens through, let's say, if there is a chikungunya or any, like, or dengue fever being spreaded across a particular region or a city. If there is a proper survey being done, and you get more information about how many people got affected, what is the source of it, what they consume, where they live in, how's the surroundings, right? That kind of gives you a lot of information about how that like some of the very spreadable diseases gets into in contact, especially virus borne diseases, right? So we can actually solve those problems in and helping predict a better, I would say, precaution for the public and the society, right? So those are some of the examples also that I can talk about here. And then you have time series data, which is like over the period of time, in last 10 years or last 5 years, what is the spread of dengue or these kind of diseases. Is it born based on, let's say, season, or it is not season wise, right? Seasonality and all those things we can check from the time series models, images, self-reported measures, and the textual information, right? So these you can actually either use prompting techniques, advanced prompting techniques, or you can use the training technique to, maybe, like, you can feed in this information to a base LLM. What is a base LLM? Can anyone tell me here? Does anyone know what is a base LLM?
Yeah,
Okay.
I can say.
Yes, Paul.
Uh, I think the pre-trained model, the pre-trained model, when you take a LLM, which is not tuned to anything, any particular data sets, which has trained on some general data sets actually. So those are actually base model.
Okay.
Hello.
Yes. Yes. I
Okay.
got the answer, Paul. Yeah.
Mm,
Thank you.
mm,
So
yeah.
Anyone else would like to answer? Trained on large unstructured data. Okay, Pramod is saying. Um, so Llama 2 and Llama 3, you have heard about. A base model for Llama 2, Llama 3 is Alpaca, which was released by Stanford, which was an open source model, and they have developed. Facebook has taken that, and Meta AI or whatever, they have taken that, and they have developed a specialized trained model. The base models are trained with, yes, largely a lot of unstructured data, and these models are not specialized models, right? For example, GPT 3.5, which was trained from GPT 2 or even the previous version of GPT. So if you take a base model and then you wanted to train with a specialized data set, you want to do fine tuning or you want to train from scratch, uh, both are a different thing altogether, right? So you have a base model which you don't need to spend that much of money in terms of GPU resources and time. You take the base LLM, and then here you get a specialized data set, and based on that you get a spatial LLM, let's say in healthcare LLM, right? Just an example. So if I have an healthcare LLM, I can now work better with it. And I wanted to do certain tasks like prediction tasks here. Yes, Srini, any questions?
Yes, please. I just wanted to little bit get a oversight about the base LLM. So when you're talking about a base LLM, so we understand that it's not trained, or does it have
They are
some kind of
trained.
semantic information embedded in it?
They are trained with lot of I mean, I would say lot of data, and they are not specialized data. For example, let's say if I'm talking about all set of domains and I take some data from each and every domain, right? Then it is not in specialized model.
Okay.
Yeah.
Okay,
So
but can we have something like it when we say that it's a specialized domain or something? But can we say that when a base LLM is there, we are developing using a transformer technology, maybe BERT or BERT, whatever is suitable, that we feel that it can gain the specific knowledge on that. But is there any particular base model where the knowledge gain is very minimal? We trained it from the very base level. I mean, there's no knowledge in it, but we take the medical literature and feed it. Something like a specialized LLM, but still it is the base LLM doesn't have what do we call it as knowledge, initial knowledge, thought process kind of a thing in it.
so lot of these models like Llama 2 Mistral, right? Their base model is Alpaca. You
Okay.
see, Stanford Alpaca is one of the good examples of a base LLM. Okay, and if you look at these, right, so they have this Meta Llama 2, which is basically built based on uh, a base model. Now they can, I mean, you call it a base model because that's your base where you are starting from, right? You cannot take a GPT 3.5 as base model because they're huge inside and there is no scope for doing training. So you take a smaller model, especially the parameters are less, and also they are not specialized, or they are not specifically trained with a particular domain, right? And let's say over the time when we get into these different type of domains, you can have an healthcare based LLM, let's say, right? A healthcare based LLM, which is like, let's say, all type of disease, all kind of specializations of the healthcare industry. They have taken that data and they trained it, but it's not a huge amount of data and not not a big LLM. Now you take that, and let's say you wanted to make it a cancer prediction LLM. Then you take cancer specific data and then you train that base healthcare base LLM, right? So the definition of base LLM is little hazy there. It's not like you will call any LLM and base LLM, but there are few LLMs that are developed and given as, like, definition of base LLM in terms of the size and what type of the variation of the data in that.
In continuation of that Srini's question, I could say that if you don't actually there is a noise. Actually, I'm at a restaurant. I'm sorry for that. So there will be background noise. So what I was saying at if you
Go ahead, Paul.
oh sorry, if you take a model and if you don't give any basic training on that, so it will be he's asking like that empty LLM if you take. So if you don't give any training, so you won't make it a. You can't say it is a model. You can't.
Exactly.
If you have to give some foundation on it,
Exactly.
unless and until you give that foundation, it won't act like a model, language model or kind of a model. So you
Exactly.
have
Yes,
to give that one first.
yes,
Exactly.
please. I was more concerned about how the data mixture could be and how could that LLM hallucinate. Does there is a chance of hallucination? Should we
Okay.
be? What is the
Hallucination is a different problem, and there are different solutions to that, Srini. The coming to your previous question, like as Paul said, the base LLM you can think of like an human, right? So if somebody has done 10 plus 12, right, a graduation, then they go for masters or they go for PhD, isn't it? So you can say that that's the base of that person to do masters in a specific area or to do PhD thesis on a specific area. So you take these base LLMs, which are like decently trained with data, got unstructured data, some all generalized data, and then you make them special.
Yeah, that's a good example. Taking the degree 10 and 12 as a base one, base education, and then you go on specialization.
Yeah.
sure? Okay, thank you.
Okay, moving on. So I have these. Let's say I have taken in healthcare. I mean, I could not cover all the problems that are there in the healthcare domain, but I'm trying to give one scenario which I took as a healthcare LLM. That is sleep disorder. Let's say if I have to determine stress, I want to determine readiness. I want to determine fatigue. I want to determine sleep quality of a person. I want to determine what is the health activity that the person is doing, what how much of calories, depression, anxiety, or stress resilience, right? All of these can be measured by an healthcare LLM. Now for that, what do we need? I'm going to also show you a quick demonstration on the that some examples through prompting in the GPT-4o model. I'll come to that. So the consumer healthcare tasks like stress or readiness or read or fatigue or sleep quality or stress resilience or sleep disorder, right? All of these are like different consumer healthcare tasks. And if we compare, and the idea behind is to take these different tasks and compare a set of LLMs, right? And also the tasks that they are trained with. So let's say if I have LLM1, LLM2, LLM3, and LLM4, which LLM, given a type of data they are trained with, the volume and the size of the LLM, is going to perform better in this kind of determination, this kind of tasks. Okay, so consumer healthcare task is like, for example, that we have taken here to understand the quality of the LLMs and the responses. What are the applications? Maybe you can generate a good workout plan based on what is the stress level, what is the sleep quality, the readiness, which is basically individual's preparedness for physical activity and exercise, and fatigue and sleep disorder or stress resilience, and right, etc. So based on that, I can prepare and can suggest a better workout plan for the individuals, right? I can also do a depression control if I know what is the level of stress they have, what is the what is the amount of sleep disorder there that's happening, what is the sleep quality. I can definitely control depression, so which is basically a mental health strategy tailored to reduce depressive symptoms through cognitive behavioral theory and lifestyle adjustment. And then you have sleep support, so we can have a sleep tracking and improving the sleep quality. So this is like some of the targeted applications based on analysis of these kind of consumer health tasks. Now, how do you do that? You might have wearable devices, you might have user surveys, you might have institutional data like from medical colleges or industries or medical or hospitals, and logging apps, etc. Right? So, and then you try to measure this task, and this is what you wanted to achieve. Let's say this is your application. So, how do we proceed with this kind of solution building? Right? The first step towards this is to choose the right LLM, right? So which is the right LLM for you? Which is the right LLM to do this task, right? In terms of size, in terms of quality, in terms of data they are trained with, and in terms of specialization, right? So all these are like the implications for that. Yeah. And other than that, if once the model you have chosen, what are the ways that you can improve the quality of the responses from the models? So as per this paper, there are three ways that we can do this. One of the methods are like, you know, the prompting techniques. In the prompting techniques, we'll use, just a minute. Yeah, so we can use zero shot prompting. I don't know how many of you are aware of zero shot, but I think most of you, if you have done work with LLMs, zero shot, I'll in single word, if I have to explain it, you are not giving any kind of examples here. Okay. So in zero shot prompting, you have a zero shot instruction, you have a context, and you have a question, and you have an output format. So you provide what output I'm looking for, what kind of output I'm looking for. Is it JSON? Is it text? Is let's say an image or description, etc., etc. And then you have a context. The context is more of like, so now very important that I am going to talk about these two things, right? A zero shot instruction and a context. So the aim of zero shot prompting is to evaluate the capability of pre-trained language models on health prediction tasks. So to this end, like, we first design a basic prompt setup. So the basic prompt is your common prompt for all type of prompt answers that you're looking for. Yes, Pranshu?
So could you throw some light on zero shot prompting in context with the healthcare thing that you told earlier?
Yes, I'm coming to that. I'll give some examples also. I think that will make it more clear. Okay. So,
Yes, sir.
so yeah. Any other questions? Sorry. So the user context, which is basically user specific information, such as, let's say, I'm looking for heart rate, or I'm looking for a blood pressure based on certain age, gender, weight, height, etc. Right? Which provides additional information that affects the understanding of the health knowledge. Let's say I start with an user context, the first one. The second one, that I give some health context. What is health context? That provides definition and equation that controls certain health targets to inject new health knowledge into the LLMs. So for example, let's say I kind of give, there is a specific symptom related to blood pressure, or there are some specific observations in the last medical report. So that can be a health context. Okay. And there is some temporal context. What is temporal context? It's an adopted to test the importance of temporal aspects in time series data. For example, instead of using aggregated statistics, we utilize the raw time series sequence. This is what is the zero shot prompting. So you have a zero shot instruction plus context plus question plus output format. Okay. Yeah, Pransu?
Yeah.
What do you mean by aggregated statistics?
I'll come to that. So if you look at these example here, the first one is the base prompt, right? So I have the analysis of recent period. Let's say the analysis of recent period 14 days averaged sensor readings show step 812 steps, burned calories 97, and resting heart rate 66.54 beats per minute, sleep minutes, and mode out of 5. Let's say it says sleep mode. And in this regard, what is the predicted readiness score level between 0 and 10? Right? This is my base prompt. So I have a very base prompt, and now I want to improve this prompt by giving an user context. What is the user context? Given the user's profile as age 23-year-old, which I did not have it here, okay? And then I'm saying the sex of the user and the height of the user. This is my user context. And then I add one more thing, that is health context. So I say readiness score is an indicator of how prepared our body is for physical activity, and it is decided by activity, recent sleep, and heart rate variability. So I give an health context here, okay, along with what we are giving as a base prompt. So I have base prompt plus user context plus health context plus temporal context. Coming to the answer that you, Pransu, you were asking. So the analysis of recent period, where I have 14 days of sensor readings, steps, burned calories, resting heart. So I have these different set instead of an aggregated value or statistics. Sleep minutes in this range, then mode 3 out of 5. So in this regard, what is the predicted readiness score level between 0 and 10? Okay, so now the LLM got more information here, and your prompt also, the prompt quality also improved in terms of the information that you feed into the LLM. Okay, now all if you combine, so it's basically a better context or a prompt for the LLM that has a basic prompt, user context, health context, temporal context, and all. Okay, does that make sense now, Pransu? Moving on.
Yes, sir. Thank you for throwing that light.
Sure. So now few shot prompting. A few shot prompting involves using a limited selection of demonstration examples. So when zero shot means there is no example provided. Okay. In the few shot, we'll try to give some examples to the model. And now I'll throw some light through chain of thought and self consistency. Now chain of thought we have been discussing in our webinars so many times, and I think a lot of people maybe already started using chain of thought, and a lot of LLMs are coming with inbuilt chain of thought reasoning. There is one area that is less discussed, that is very much important and very effective, that is called self-consistency prompting. Self-consistency prompting is more advanced version of the COD, and I'll give some light on that as well. So I have a context, I have a healthcare context, I have a user context, and I have, let's say, temporal context, and then time series data. So my few shot prompt, the few shot prompt will be instruction, few shot instruction plus context plus question and the answer plus the prompt. So basically in COT or chain of thought, what we do is, let's say you tell a kid to calculate how many apples are there in a basket. Then you give that kid 2 baskets and say that how many total apples are there in the 2 baskets. How the kid will count it? He or she will take each and every apple, and he will remember that, and he will keep them back in the basket, and he'll give you the count. In case of LLMs, if I have to, let's say, give a problem, a mathematical problem, where I say, like, I had 3 apples at the beginning, and now I have added 2 more apples. How many apples are there? You can ask prompt like this. So the LLM will give you, let's say, 5 apples, because you had 3 and later on you added 2 more. In chain of thought, you do not give the prompt like that. What you do is, you first tell that if there are 3 apples and you added 2 more apples, the answer is not just 5. So you give an example of how you should answer. So the answer should be like, okay, as you had 3 apples before, and now you have added 2, ideally we should sum them up. So the sum of 3, which is previously added, and the 2, which is later added, got 5. So the answer is 5. That's how you actually give an example of the answer. So it's kind of the chain of thought reasoning. It's called chain of thought reasoning. And in this process, the first method was like just to give an answer as 5 as number. In the second contextual reference, you give a detailed answer and a step-by-step explanation of how you come to the answer 5. Does that make sense about chain of thought, everyone? So let's look at an example. So generally in context, we have you provide some additional information. Now I'll come to that slide later and maybe not required as of now. So in the chain of thought process, you have this, let's say you have a greedy decoding. So in the greedy decoding process, you say that this means she has 3 plus 4, 7 eggs every day. So she sells remainder for $2 per egg. So in total, she sells 7 into $2, which is $14 per day. So the total answer is $14, and this is the answer. Now if I use self consistency, which this paper which got basically published, not the current paper that we're discussing, but this is I have taken from wait till 2023 a paper, and they have basically says that with self consistency reasoning you can improve the LLM quality or response to like 10 to 20x more than COT based reasoning, right? So if there are 3 cars in the parking lot and 2 more cars arrive, how many cars are there in the parking lot? So here what you do is, instead of giving one example, in the COT we give one example and that's it. So the model learns from it and it tries to give you an answer. In the self consistency reasoning, what you do is you will give sample a diverse set of reasoning paths. So maybe there are, let's say if there are 3 kids who are actually doing this calculation, they might come up with different answers based on their reasoning ability. So let's say she has 16 minus 3 minus 4, 9 eggs left. So she makes 2 into 9, which is 18 is the answer. So 18 per day. And then another example, this means she sells remainder of $2 into 16 minus 4 minus 3. The answer is 26. So 26 per day. And then another way to calculate the same thing. And now the answer is 18 because I've got most of the times 18. So the marginalized out reasoning paths to aggregate final answer. So these are like, you are kind of giving this to the LLM to come up with sample diverse reasoning paths, and this gives you the final answer. All right, make sense? So this is basically a self consistency reasoning. And then the other step is instruction tuning. So instruction tuning is a technique where all parameters of the pre-trained model are further trained or fine-tuned on a target task. So this is basically you use GPUs, you use new set of data or specialized data to tune a model, where you do an instruction tuning. It's not a prompting technique, but rather a instruction tuning method. So instead of fine-tuning all parameters, methods like LoRa, which is a low-rank adaptation technique, involves training a small proportion of the parameters. So you basically have, let's say you have a 7 billion parameter model, you freeze that, and then you use a LoRa technique where you actually train a model with a new set of data. And this is basically you form another matrix and then you combine that and then get your model. So you don't really change the original weights of the LLM. I mean, and very short, I'm explaining this. So in health LLM context, these parameter efficient fine-tuning techniques enable the model to adapt to healthcare tasks while maintaining computational efficiency. Basically, what happens if you take a large model like GPT 3.5, and let's say you take a lot of cancer data, what will happen is the question from Srini earlier, like how do we solve hallucination problem? So if you do this right with just train on a specific data to a huge large language model, it will create an problem called catastrophic forgetting, where the model tends to forget what it was originally trained with, and it basically doesn't remember a lot of stuff that it was actually trained with, and it dominates the data or knowledge with the cancer data set that it has recently been trained with, and it creates a lot of hallucination problems there. To solve that problem, one of the technique is to use LoRa, or low rank adaptation, where you do not change the original weights of the LLM, but rather you get another matrix trained with this, then you merge those two matrices. And it's a layman term, I'm explaining it, but LoRa is a different paper altogether. If you wanted to go and read that paper, it has detailed steps of how the LoRa method works. Okay, so in the low rank adaptation technique, you have an efficient way of training this model so that you don't see this hallucination or any kind of catastrophic forgetting problems. Okay, and the other technique is like you take all the, so if you have a cancer, all you take different set of data set, but you have this data set ready and prepared to train a large language model. This is like computationally very heavy, and it is not really possible in all scenarios unless you are like a big LLM provider company. Okay, so the other thing that I wanted to discuss about is the evaluation of the model given the time. So we already have 1 hour, so I'll quickly have some demo around it, and then I'll go to evaluation part of the of these healthcare LLMs. So what I will do is I will take these prompts and let me clear this up. So I have told this model already as a system prompt. This is GPT-4o. Okay, I'm using GPT-4o, and I told like act like a large language model for health predictions via variable sensor data. Help me answer in an organized and markdown text always. And because I want to get it marked down so I can show you the result properly. And then I gave an example that how you wanted to give a question and the answer to that. So now I'll just take this data from here, which is basically the base prompt. So let me get this, the analysis of recent period, 14 days average sensor readings, show steps and these, and in this regard, what is the predicted readiness score level between 0 and 10. So this is what I want the model to answer me given this prompt. Now, if I give this prompt, how this GPT-4o model is behaving, let's see the answer. Okay, so let me run it here.
Can you please explain instruction tuning once again?
Yes, sure. I'll do that in a couple of minutes. So once I show this, okay. So now I'll just go and show you the result here. So if you see here, the question is the analysis of recent period with the same thing, the predicted readiness score level. So based on the provided average over the past 14 days, these are the steps, burn calories, resting heart rate, sleep minutes, and mode, right? 3 out of 5. The model got this, and we can analyze each factor contributing to the readiness score. For example, steps 812 steps. This means this is significantly below the typical recommended daily step count of 10,000 steps. Low physical activity could contribute to lower readiness score. Burn calories. So similarly, this calorie expenditure is relatively low, suggesting a sedentary lifestyle, which again could lower the readiness score. And resting heart rate, sleep minutes, and mode, right? So all these are like, so what is the final prediction? Given the combination of low physical activity and calories burned, but good sleep and healthy resting heart rate, the readiness score can be estimated as 4 out of 10. So that's what we are getting here based on a base prompt. Now let's improve that, and I give a temporal context and everything. So I'll take the last one, that is the all, which is basically I give a readiness score, and I give a User context. So I said readiness score is an indicator of how prepared our body is for physical activity. It is decided by activity, recent sleep, and heart rate viability. So I have health context, I have user context, I have temporal context, right? And then I ask this question. Now let's see how the model is answering. So now, if you see this, right? So these are the steps: burn calories, resting heart rate, sleep minutes, and mode. Now you see the presence of NaN, not a number, indicates some missing data. The available data like 991 steps are still relatively low, obviously, and here also it is low. Resting heart rate is also, which is typically healthy for a young 23-year-old male. So now, as it knows, it's 23-year-old male, and the heart rate is between 60 mid to high, right? So resting heart rate, and it is able to get around that. So it's saying that's good heart rate for a 23-year-old male. And sleep minutes is like 450, 455, 534, averaging at about 7 to 8 hours per night, which is healthy. And mode also saying in mode rating of 3 out of 5, which is neutral. Now it is saying 5 out of 10, final predicted readiness score. So your better context also helps the LLM to give you a better answer, isn't it? So this is one of the examples of how we can improve the output from the LLMs. Let's move on. And there was a question, right? That what is the question that you have asked? Sorry, the last question.
Instruction tuning, how it
Yeah.
is
So
happening.
instruction tuning is more of like, as you know, how you do fine tuning of a model. Yeah. So you take a lot of data, not a lot of data. If you have even a good amount of domain specific data, and you can use different techniques. One of the very popular technique is LoRa, because it uses low rank adaptation technique, which is basically a very efficient method to do fine tuning of the models. Okay, so instruction tuning is a technique where all parameters of a pre-trained model are further trained or fine-tuned on a target task. So my target task is, let's say, heartbeat quality, for example. Okay, so I will take all types of heartbeat quality related information, all different diverse segments of folks in, and also the age, and like, and other different diseases that they carry. So if I give more information on that data and then I do a fine-tuned model, that model will know much more about the heart rate prediction than any other generalized model. Yes, Reni?
Yes, please. One generalized question. Just wanted to understand, like, based on all these three, like even we have talked about tuning, we have talked about prompting, and there's also a RAG, retrieval augment generation, which can, effectively get to what level we want it to answer in the based on the context. So, according to your experience, what would be some of the best technique or which has proved effective to, effectively get the right solution, kind of a thing?
Yeah, you mean the better, which is a better approach?
Yes, please. Yes, please.
Yes, I will come to that, Srini. So my last two slides are based on that.
Okay, thank you.
Yeah, sure. So the evaluations, there is an open medical LLM leaderboard, and this leaderboard is like benchmarking the LLMs. The benchmarking of LLMs are very important in terms of how do you measure the quality of these models, right? So if I go back to my leaderboard slide, um, just a minute. Yeah. So if you look at these, right, we have BERT-like models like GPT-3, GPT-2, which are like very big, and then we have BioBERT, SciBERT, ClinicBERT, BlueBERT, PubMed, BERT, and Med CPT. So they're like very specialized models, and they're around and less than 10 billion parameters. So you can see like the increase of the parameters, right? So GPT-3 and GPT-4 is more than 1000 is like 2000 parameter model, which is like way beyond all the models that you have here. Now, there are some chat GLM or llama like models like BNQ, then you have Chat Doctor, we have ClickMate, you have Bentasco, Med Alpha, AlphaCar, Care, and PMC Llama, Clinical Camel. All these are like within that range. And then you have GPT based flavors, PAM like models like BioGPT, Biomed LLM, right? Clinical GPT and MadePalm and MadePalm. So MadePalm become very famous and it's a 540 billion parameter model, which is really good. Now, if you see the answers here, so basically, when models are used for recreational conversation aspects, errors have little repercussions. This is not case for uses in medical domain. However, where wrong explanation answers can have severe consequences for patient care and outcomes. So the accuracy and reliability of information provided by language models can be matter of life or death, right? So as it could potentially affect healthcare decisions and diagnosis. So when given a medical query, GPT-3 GPT-3 incorrectly recommended tetracycline for a pregnant patient despite correctly explaining its contradiction due to potential harm to the fetus. Acting on this incorrect recommendation could lead to growth problems in the baby, right? So the physician says amoxicillin, where the GPT 3.5 says tetracycline. This is one of the examples that how it can behave incorrectly. So to fully utilize the power of LLM in healthcare, it is crucial to develop and benchmark models using a setup specifically designed for the medical domain. And I would further say specifically designed for a medical task. Okay, and this setup should take into account the unique characteristics and requirements of healthcare data and applications. So this leaderboard, which is like designed based on different type of data set that they have performed on and different type of tasks that they have checked this. So MadeQA is a data set consists of multiple choice questions from United States Medical Licensing Examination, USMLE, and it covers general medical knowledge and includes 11,450 questions and developed a set of 1,200 questions in the test set. Now this has each has 4 to 5 choice multiple choice questions and answers. This is one of the data set that we can talk about, MadeQA. And then we have MadeMCQA, which is basically a large scale multiple choice QA questions, which has one like 87,000 questions, and it developed set of 61,000 questions in the test set. And then we have PubMed QA, which is again, it consists of 1,000 expert labeled question answer pairs. Each question is accompanied by a PubMed abstract as context. And the text is provided a yes, no, maybe answer based on information, which we should know like what is the data set basically being used for these models to train. And then we have our benchmarking, sorry. And then we have MMLU subset. So MMLU benchmark is measuring massive multitask language understanding, and they took a subset of it, which is medicine and biology. It's a huge data set, and they have clinical knowledge of 265 questions assessing clinical knowledge and medical genetics. So what they do is in this data set, you test the LLMs, right? And the ability to answer from the LLMs. And then you see the quality of the models based on the answers that the model is giving based on this type of benchmarking data sets. So if you see the insights here, I hope this is visible to all of you. The image, sorry. Yeah. So if you see here, GPT-4 base, it scored in the MadeMCQA around 87. In this case, also GPT-4 base is top 73, GPT-4 base 86 in PubMed QA. MMLU GPT-4 base has 85.2, and then you have MMLU clinical knowledge, GPT-4 base, GPT-4 base, GPT-4 base. So GPT-4 base has pretty much dominated this, isn't it? And this is the like biggest model that we have ever now so far, right? So, and if you see Google's model like Gemini Pro demonstrates strong performance in various medical domains, particularly excelling in data intensive and procedural tasks like biostatistics. So where they are very much good here, 93.8, 93.8, 93.8. So GPT-4 made palm 2 and made palm, which is basically very much a specific trained data set, and this also performed good with mmlu professional medicine benchmarking. Okay, and there are some places where these are like almost above. The medpalm 2 is above GPT-3, GPT-4, right, in mmlu college medicine. So we need to see that how these comparisons are made and where these models are doing better, right? Now I'll come back to these slides here. And if you look at this, the other question that you have is which can go better in terms of where we can perform the models can do better. So if you see user context, it has like average improvement of 10%, which is not significant. But if you see temporal context and health context, that gives you almost 22%, right? So which is significantly higher in terms of average improvement. And the best improvement that you can see here, like Atlas, which is a 3.50. And if you see here, Palmyra Med has 44.58, which is the bestest improvement. And then we have live snaps in terms of data set. So there are two things here that we are talking about. Three things. One is the context, that the prompt quality. Then we are talking about the model, the type of model that you are using. And then we are talking about the data set the model is trained with, right? So here live snaps is the data set that these paper has explained about and got the models trained with, and they kind of see the performance is better there. So made alpaca, when I want to give some last 3-4 insights from this paper, which is very crucial to all of us. Made alpaca, when fine-tuned on same dataset with the target task, mostly shows the best performance compared to when fine-tuned on other datasets. We also observed that while dataset specific fine-tuning often fail to predict tasks from other datasets, the multi-dataset fine-tuned health alpaca exhibited reasonably or generalization performance across tasks. So a lot of times what happens that you lose the generalized answers, right? Because if you have trained with a specific task. So we made an intriguing observation regarding the synergistic effect between certain datasets. In few cases, such as AWFB and STRS and live snaps ANX, performance of the fine-tuned models surpass that of the zero-shot and dataset specific fine-tuning approaches. So what they are saying is, in a lot of cases, the dataset improved more than the few shot and zero shot techniques. Okay, and if you see Palmyra, right? So Palmyra Med is the top most model that performed 44.58% improvement. That's shown improvement when adding temporal context. And Palmyra Med's significant improvement can be attributed to its fine-tuning with two medical datasets: PubMed QA, a resource-focused question answering in the medical domain, and MedQA, which provides a broad range of medical questions and answers. So by integrating them temporal context, Palmyra Med leverages its enhanced medical literature comprehension and temporal pattern recognition. So while I would say, like, let's say GPT-4 is way costlier and sometimes it's very open, so you can't use it in medical domain, but you can use some of these closed LLMs, deploy it on your own cloud or VPC or virtual private cloud, and then make use of these models effectively to solve your medical problems. Because let's say if the Palmyra Med is giving you better results, I don't need to go for GPT-4 because it's sufficiently good enough to give you that kind of quality of answers. Okay. All right. So that's pretty much it that I wanted to discuss. And I hope that you guys have a good understanding here. And this is like just the beginning of these webinars. And I'm very excited to take other set of webinars more in depth and more detailed around healthcare. And as we go further with these webinars, please like continue to attend this so that we have a good connect over the time, and I have to give less context in what we have discussed before and what we are going to discuss later on.
One question is for those results, what kind of code they have used to get the results of 97, 98, 80? For that, um, did they use gradient descent, or what kind of algorithms they used? Did they mention in this paper?
F1 score. So they have, you mean the how they have calculated the accuracy, right?
No, 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 not performance. The actual during experiments, what type of code they use, means their actual code, or how they get these results.
So
What
these
kind
are
of
my
methodologies they used.
generally, if you see these papers and if you have seen Partha, none of the papers, if they are not specific to a model, let's say pyramid, right, then you have to go for that model and see if how much they have exposed that code. Here they haven't given that detail about what code and what improved it, because I think the more focus in the broader level. And I think
So
code
how
and
they
I mean, I can tell you from my personal experiences, like if you're talking about mixture of expert and all those things, is it?
yeah.
So mixture of expert, we need to know at each model that we have discussed in this session, which of the models are like trained with MOE. They haven't discussed that because it's not a model specifically for the model architecture based paper, but it is more of like application based paper.
Can you share the link of the paper?
Yeah, sure. Why not? Let me put it in the chat. 1 second. Yeah, here you go. All right.
Sir,
Yes, Franz.
if you don't mind me asking, like we just saw on your LinkedIn profile, there was a hackathon listed that is going to happen on 20th September. So,
Yeah.
are there any prerequisites for us to join in that hackathon, or we can just go in and register and we are good to go?
Yes. If you know LLMs and you can effectively perform in that, you can go for it. There is no specific criteria.
Can you tell us in brief what you're gonna do in that hackathon?
Maybe we can share the blog or the link to that. I think Vivek, if you can help me with that.
Yeah, I'll share the meetup page. You can just find the details there
Yeah,
and register for next Saturday in Bangalore.
Okay, sir. Thank you. That works.
sure. Okay. Any other questions, folks?
So this will be, a series of weekend webinars by Indrajit and team. Then it will culminate into a series of courses which we'll launch in November. We already have one GenAI for healthcare course. Dulcie is presenting now. Indrajit will have a course series from November, but till then we'll be doing these unplugged healthcare webinars. And we want to create a community of healthcare and AI experts and do some moonshot innovation together. So if you're interested in internship in our CellBot product team, reach out to us. You can be a Gen AI expert or you can be a healthcare pharma expert. Either is fine because the value lies at the intersection of the two. Uh, so with that, we come to an end. Any final comments, folks?